Wilt is a fine basketball player, but his free throw shooting could use some work. For the past 3 seasons, he has made only 56% of his free throws. His coach sends him to a summer clinic to work on a shot, and when he returns, his coach has him step to the free throw line and take 50 shots. He makes 34 shots. Is this result convincing evidence that Wilt's free throw shooting has improved? We want to perform a simulation to estimate the probability that a 56% free throw shooter would make 34 or more in a sample of 50 shots. Okay, so for this simulation, we're assuming that he's still a 56% free throw shooter, and we want to know what's the likelihood that he could make 34 or more of those 50 shots purely by chance. Okay. If we find that it's somewhat likely, then that'll be our conclusion, that it happened purely by chance. But if we find that it is unlikely, meaning it would happen less than 5% of the time, then we will conclude that there's convincing evidence that his shot has improved. Okay, so question 5, which of the following is a correct way to perform the simulation? Okay, let the integers from 1 to 34 represent making a free throw, and 35 to 50 represent missing a free throw. Generate 50 random integers from 1 to 50. Count the number of made free throws. Repeat this process many times. Okay, so if these digits represent a made free throw, right, then that's 34 out of a possible 50 digits that we're using for the simulation, which would be not approximately, it would be exactly 68%. Okay, but we are trying to simulate that he's still a 56% free throw shooter. Okay, so option A is not going to work. Okay, option B, let the integers 1 to 34 represent making a free throw. Okay, so for the same reason, right, those digits, right, would be simulating a 68% shooter, and we want to be simulating a 56% free throw shooter. Okay, so B is not it either. All right, C. Let the integers from 1 to 56 represent making a free throw, and 57 to 100 represent missing a free throw. Okay, so this so far is good because those digits would represent 56% of the digits we're using in our simulation. Okay, generate 50 random digits. Okay, that's good because there's 50 shots that we need to simulate. Count the number of made free throws. Repeat this process many times. Okay, that sounds good. All right, let's read the rest. D, let integers from 1 to 56 represent making a free throw. 57 to 100 represent missing it. Okay, that's good. All right, generate 50 random integers. Okay, so the difference here is that this says no repeats. Okay. All right, so if we said no repeats, okay, so let's say the first digit that our random number generator produced was 22. Okay, so now, and this would be a made free throw. Okay, so now when we go to generate the next digit, 22 is no longer possible if we're saying no repeats. Okay, which means there's only 99 numbers that we can generate. Okay, which means that we no longer are simulating 56% anymore. We're actually simulating something less than 56%, right? There'd only be 55 possible digits representing makes. 55 out of 99 is 55%, 55.5%. Okay. So this is a case where we want to allow repeats because we want every free throw to have that 56% probability. Okay, so we need to allow all 56 of those digits, integers, to have a chance to be generated on any shot. Okay. All right, so D is incorrect because of the no repeats part. Okay. All right, so I like choice E. Now, what would that look like? let's go to favorite website. Okay, so look, it's already set up. Min 1, max 100. And so we would just hit this 50 times. So that'd be like a miss. That'd be a miss. That'd be a make. That'd be a miss. That'd be a make. And so on, right? So we would generate 50 numbers to represent the 50 shots. Repeats would be okay because we want every shot, every time we hit this button, to have a 56% chance of a made shot. All right, question 6. The dot plot displays the number of made shots in 100 simulated sets of 50 free throws. Okay, so think about it. This dot represents a simulation where he made 36 out of 50 shots. This dot represents a simulation where I'm going to guess that's 17 out of 50 shots. Okay, and this dot here represents a simulation where we made 30 out of 50 shots. All right, which of the following is an appropriate statement about Wilt's free throw shooting based on this dot plot? Okay, so we're assuming that he's a 56% shooter, and we want to know the likelihood that he would make 34 or more shots. Okay, so 34 or more, so this is Wilt's result, his actual result when his coach had him shoot, right? So there's 3 dots there out of 100 dots in this simulation. All right, 3%. All right, so in other words, the likelihood of a 56% shooter making 34 or more shots is incredibly low. It's very unlikely. So I think we've got convincing evidence that he really isn't a 56% shooter anymore, that he's actually improved his shot. Okay. All right, so let's make some statements here. So this is statistically significant, or we have convincing evidence that his shot has improved. Okay. All right, so let's go through the answer choices and find the best one. A, if Wilt were still only a 56% shooter, the probability that he would make at least 34 of his shots is about 0.03. Okay, that seems true, right? Remember, we are assuming that he's a 56% shooter, and there's a 3% chance that he would make 34 or more shots. Okay. B, if Wilt were still only a 56% shooter, the probability that he would make at least 34 shots is about 97%. Okay, so let's kind of clarify this. At least 34 means greater than or equal to 34, right? Which is the part that we've highlighted here. So that part is 3%. Okay. All right, so B is false. If B said 34 or less, right, then yeah, that would be 97% if we were looking at less than 34. Okay, C, if Wilt is now shooting better than 56%, well, already that's not what we're simulating. We're not simulating somebody who's shooting better than 56%. We're simulating somebody who's still a 56% shooter. So C is false. Okay, for the same reason, D is false. E, if Wilt were still only a 56% shooter, the probability that he would make at least 34 of his shots is about 1%. At least 34, again, that means greater than or equal to 34. So we want to count all 3 of these dots, not just the 1 dot on 34. So E is false. Okay, so A was the true statement all along.